Hello guys, so today we are going to discuss about the different computer paradigms and its applications. The topics which we are going to discuss are distributed computing, grid computing, cluster computing, utility computing, parallel computing, cloud computing, quantum computing and edge computing. So let us discuss these topics one by one. First is distributed computing. Distributed computing is defined as a type of computing where multiple computer systems work on a single problem. All the computer systems are linked together and the problem is divided into subproblems where each part is solved by different computer systems. The goal of distributed computing is to increase the performance and efficiency of the system and ensure fault tolerance. Distributed systems may have a shared goal such as solving a large computational problem collaboratively. Alternatively, each computer may serve individual users, coordinating resource usage or providing communication services. So these are the advantages of this computing: highly efficient, scalability, less tolerant of failures, high availability. The applications of distributed computing are large-scale data processing, for example, web search engines, social networks, scientific simulations, example, weather forecasting, protein folding. And the last is fault-tolerant systems, example, banking transactions, stock exchanges. So this is all about distributed computing, and here is the diagram of distributed computing. So the next topic is grid computing. Grid computing is defined as a type of computing where it constitutes a network of computers that work together to perform tasks that may be difficult for a single machine to handle. All the computers on that network work under the same umbrella and are termed as a virtual supercomputer. The task they work on is of either high computing power and consists of large data sets. All communication between the computer systems in grid computing is done on the data grid. The goal of grid computing is to solve more high computational problems in less time and improve productivity. The advantages of grid computing are scalability, efficiency and reliability, cost effectiveness, application oriented. The applications of grid computing are large-scale scientific research, resource-intensive computations, entertainment, and also for engineering purposes. So this is all about grid computing, and here is the diagram of grid computing. The next topic is cluster computing. A cluster is a group of independent computers that work together to perform the task given. Cluster computing is defined as a type of computing that consists of two or more independent computers, referred to as nodes, that work together to execute tasks as a single machine. The goal of cluster computing is to increase the performance, scalability, and simplicity of the system, help to solve the complex operations more efficiently with much faster processing speed. The advantages of this computing paradigm are processing speed, cost efficiency, high availability of resources, expandability. The applications are Google search engine, earthquake simulation software, image rendering, weather forecasting. In these fields, the cluster computing is making use of. So this is the diagram of cluster computing. The next one is utility computing. Utility computing is defined as a type of computing where the service provider provides the needed resources and services to the customer and charges them depending on the usage of these resources as per requirement and demand, but not of a fixed rate. Utility computing involves the renting of resources such as hardware, software, etc., depending on the demand and the requirement. The goal of utility computing is to increase the usage of resources and be more cost efficient. So the advantages are flexibility and agility, cost reduction, streamlined IT management. The applications of utility computing are cloud computing services, example Amazon Web Service and Microsoft Azure. Scalable web applications, example online shopping, streaming services. So this is a diagram of utility computing. So this is all about utility computing. The next one is parallel computing. Parallel computing is defined as a type of computing where multiple computer systems are used simultaneously. The problem is broken into sub-problems and then further broken down into instructions. These instructions from each sub-problem are executed concurrently on different processes. There are different types of parallel computings are there. They are bit level parallelism, instruction level parallelism, data parallelism, task parallelism. So the bit level parallelism involves processing multiple bits of data at once. Instruction level parallelism executes multiple instructions concurrently. In data parallelism distributes data across processes for parallel processing. In task parallelism divides tasks into independent subproblems. The advantages are speed, resource utilization, scalability. The applications of parallel computing are scientific simulation, example fluid dynamics, nuclear simulations, image and video processing, example rendering and compression, cryptography, example breaking codes, secure communication. So this is the diagram of parallel computing. So the next one is cloud computing. Cloud computing is a paradigm that provides on-demand access to computing resources such as servers, storage, databases, networking, software, and analytics over the internet. It allows individuals and business to use computing power without having to invest in and maintain physical hardware. Users pay only for the resources they use. That means it is pay as you go. The characteristics of this computing are on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. There are so many characteristics for cloud computing. Cloud service models. Infrastructure as a service, IaaS, provides virtualized computing resources over the internet. Example, Amazon Web Service, Microsoft Azure. Platform as a service, PaaS, provides a platform allowing the customers to develop, run, and manage applications without the complexity of building and maintaining the underlying infrastructure. Example, Heroku, Google App Engine. There are three cloud service models. The last one is software as a service, SaaS. Delivers software applications over the internet on a subscription basis. Users can access these applications through a web browser, reducing the need for local installation. Examples, Google Workspace, Microsoft 365. So the next one is cloud deployment models. There are three cloud deployment models: public cloud, private cloud, and hybrid cloud. We can discuss these three one by one. So the first one is public cloud. The cloud infrastructure is owned by a third-party cloud service provider and made available to the general public. That means the public cloud can be accessed by everyone. Example, Amazon Web Service, Microsoft Azure. The next one is private cloud. The cloud infrastructure is operated solely for a single organization, whether managed internally or by a third party. And the last one is hybrid cloud, a combination of public and private clouds allowing data and applications to be shared between them. So the advantages of cloud computing are cost efficiency, scalability, flexibility, maintenance, and collaboration. The applications for cloud computing are data storage and backup, software development and testing, big data analytics, content delivery, and streaming. So this is the diagram for cloud computing. From this diagram, we get an idea about cloud computing. So the next one is quantum computing. Quantum computing is a revolutionary paradigm that leverages the principles of quantum mechanics to perform computations that are fundamentally different from those of classical computers. Unlike classical computers, which use bits as the smallest unit of data, quantum computers use quantum bits or qubits. Qubits can exist in multiple states simultaneously, thanks to quantum phenomena like superposition and entanglement. Quantum computing is an active area of research with ongoing advancements in hardware, algorithms, and error correction techniques. Major tech companies like IBM, Google, and Microsoft, along with startups and research institutions, are working to develop practical quantum computers. So the advantages are exponential speed up for certain problems, improved optimization, efficient simulation of quantum systems, parallelism and superposition. So the applications for this computer paradigm are cryptography, drug discovery and chemistry, optimization problems, climate modeling and simulation, financial modeling, artificial intelligence and machine learning. So this is all about quantum computing. So this is a simple picture for quantum computing. So the last computing paradigm which we are going to discuss in this video is edge computing. Edge computing is a computing paradigm that brings computation and data storage closer to the location where it is needed, typically near the sources of data such as IoT devices, Internet of Things devices, sensors or local servers. This approach reduces latency, saves bandwidth, and improves response times by minimizing the distance data needs to travel, especially in applications where real-time processing is crucial. The concepts for this computing are proximity to data sources, low latency, reduces bandwidth use, improved reliability, security, and privacy. The advantages for this edge computing are reduced latency, improved bandwidth efficiency, enhanced privacy and security, scalability, greater reliability and resilience, real-time data processing, lower operational cost. The applications of edge computing are Internet of Things IoT, autonomous vehicles, healthcare, industrial automation, content delivery, and media streaming, telecommunications. In this field, we make use of edge computing paradigm. So this is a simple diagram for edge computing. Here ends our video presentation. I hope you guys get an idea about these computing paradigms. Thank you.